Next ready. So let us try to talk about your very important topic, that is about your geometrical and optical path length and optical path length. Okay. What do you mean by your geometrical path and what do you mean by your optical path? Okay. Let's say for example, if I'm talking about a certain sheet, let's say for example, I'm taking here a small sheet, something like this. Okay. And an ray of light is beam. It is made up of, like say for example, refractive index mu, and thickness of this sheet is right now, say for example, T, like a plastic sheet. Okay, the light is traveling from point A to your point B in the sheet. It is traveling this distance, which is having a refractive index of your mu. Okay. Now, if I say that whatever the distance it is traveling in this sheet, which is called as of an optical path. Okay, what is actually geometrical path for this one, beta? A to B will be your geometrical path. It will be your geometrical path. Geometrical path will be equal to AB. That will be equal to your thickness T. If I'm talking about optical path, that means when it is passing through the thin sheet of your mica, it will be equal to how much or beta? A and B dash. Like say, for example, if I take here, it will be some extra distance traveled in the air. So it will be your A and B dash. That will be equal to mu times of your thickness of your T. That means this value will be equal to your mu times of your T. This point you need to remember. What is the condition? When it is passing through the geometrical path, it is T. And when it is passing to the optical path, it will be mu times of your T. Okay. So whenever a sheet of mica, a sheet of your plate having thickness T is been kept in front of a light, the distance traveled by that one will be equal to mu times of your T. Okay. Now let us try to come to our actual path. That is, if a thin sheet of the film, if a thin sheet of film is kept in YDSC, okay, thin sheet of sheet is being kept in front of your YDSC. What is the YDSC? But yesterday I told you, YDSC is nothing but like this. It is a one sheet here, and there is one more sheet in front of this one. Okay, and light has been passing through this one. There are the small holes we are making this one. Sorry. Okay, we are keeping one more sheet in front of this one like this. And small eraser, so taking small holes right. These are acting as of your sources S1. This one is your S2. The distance between the screen and the slit will be equal to capital D. This one is known as of your screen and this one is known as of your slits. Distance between them is equals to your D. Distance between them is equals to your D. When light is being passed from this source, this is a parent source. When a light is being passed through this one from here and from here to here like this will be your central maxima. And somewhere here, the ray of light is being incident. Let's say, for example, there's somewhere here, the point of ray is being distance between them is D. Am I clear? And what I'm doing is I'm keeping a thin sheet of your mica. Like say when you see a 3D movie, you will keep the specs in front of that one, something like this. This is a small sheet of your paper or thin sheet, which I'm keeping in front of this one. So this one is your thin sheet having a refractive index of your mu and thickness of this one is equals to D. In that case, how do you calculate the position of your bright or minimum? Let's see when these rays of lights are interfering and this one beta, when this sheet was being not kept, it was exactly being incident at a point of C. When you keep this sheet, because of this sheet, then it has been traveling some extra distance. That extra distance I need to calculate. That means I need to calculate the shift in the fringe pattern. So how do you calculate the shift in the fringe pattern? Shift in fringe. Shift in your fringe. That means somewhere here it is been gone, like say for example. This one is right now, for example, y. So the fringe shift is given by the formula y is equals to thickness T into your capital D into mu minus 1 in divided by your small d. So this is a formula you need to remember. So whenever some sheet of your paper is been kept in front of one of the slit, the point of C is been shifted to C dash. That is called as a shift in the fringe width. The shift in the fringe width is given by the formula y is equals to T is your thickness, capital D is the distance between the screen and slit, mu is the refractive index and divided by distance between them. Very, very important formula. So y is equals to your T into D mu minus 1 divided by your small d. Am I clear with this formula? Am I clear?
Yes, sir.
Sure. I will ask you some questions even in the competitive examinations beta. In YDSC, if white light is being used, white light is used in YDSC, what happens? So instead of monochromatic ray of light, here what we are using, this is your monochromatic ray of light. Monochromatic ray of light means either I'm doing the experiment with blue light, yellow light, or anything, but one color. But if I'm using the, instead of monochromatic light, if white light is used in the YDSC, what are the points you need to remember for doing the theoretical question? The first point you need to remember is the central bright, whatever you're getting, the central bright fringe is white color, is your white color. Okay, that is a point number one. Point number two, as you move little away from, you will be seeing the reddish color first. Okay, as we move a little away, we see a reddish color. Okay, violet will be destructive interference better. If you see the violet color, violet is your destructive interference. Okay, this point you need to remember. So what is the first point you will be remembering? Instead of monochromatic ray of light, if you are using your white light, the central bright fringe will be your white. The central bright fringe will be your white. That point you need to remember. Now, in the same way, if I'm talking about this given condition, as we are moving a little away, we see what type of a color better right now there? We are seeing your reddish color. And if violet color comes, violet represents me the destructive interference. These are the theoretical points you need to remember. And one more theoretical point you need to remember, more further away from that one, if we move more away from it, the color will be, anyone better? What will be the color? The color will be your bluish. The color will be your bluish color. This is also a theoretical point you need to remember. What is the central maxima you will be seeing? You will be seeing the central maxima white, followed by reddish, followed by your blue color. If you are seeing the violet color, that will be representing me the destructive interference. Am I clear?
Yes, sir.
Now tell me maximum intensity formula क्या होता है बेटा? Imax का formula बताइए. What is an Imax formula? Imax is equals to root of your I1 plus root of your I2 into your whole square. And what is I minima formula beta? I minima will be equal to your root of your I1 minus root of your I2 into your whole square. Okay. So that was about the little bit story related to your YDSC experiments part of relations. Just go through this one better formulas. We'll try to do some problems based on this one. Here in this one, he will be asking a question that if the distance traveled by the light in the thin sheet is AB, what will be the same length it will be traveling in the air. The answer will be mu times of t. Mu is your refractive index. If a thin sheet of mica is being kept in front of IDSC, the shift in the fringe width is given by the formula T into capital D into mu minus 1 divided by your small d. When white light, if it is used, the central point will be white color, and then followed by the reddish, then followed by your bluish. Imax formula will be equal to how much for me? Root of your I1 plus I2 whole square, and I minima will be equal to your root of your I1 minus of your root of your I2. Am I clear? Here, if it's asking some other points better, what is the path that is the weight? If you calculate the path difference in this one, path difference is calculated by the formula delta phi is equals to 2 pi by lambda into your mu minus 1 into your thickness t. So this will be the phase difference when a sheet of mica is being kept. Okay. And path difference will be delta x is equals to mu minus 1 into your thickness of your t. Path difference will be mu minus 1 into your t. Okay. Sure. Now this is something very important. How do you calculate the number of fringes? How do you calculate the number of your fringes? Okay, number of fringes can be calculated with the formula beta. N is equals to your shift in the fringe width divided by distance between the string. That means if I directly write the formula, I can use here as of your fringe width. That is nothing but equal to beta. So number of fringe width can be calculated by the formula y naught divided by your beta. What is the y naught formula beta? Y naught is nothing but of your shift. That is right now for me. What is the formula I got here? T into your D. This one is a T into capital D into mu minus of your 1 divided by your, this is right now for me your small d. This is your small d multiplied by beta. What is the beta formula beta? Anyone? Beta is equals to capital D into lambda divided by your small d. Small d will get cancelled. D and D will get cancelled. So the number of your fringes shifted can be calculated by the formula mu minus 1 into your thickness T divided by your lambda. That will be the formula for this one. In terms of your refractive index, N is equals to mu minus 1 into your T. Okay. So the number of fringes which have been shifted when a thin sheet of a mica is being kept in front of one of the slit can be calculated by the formula N is equals to mu minus 1 into T divided by lambda. Am I clear? No doubt in
Yes.
this one? Done, beta? Sure. See this question, beta. Light of wavelength 5000 angstroms is traveling in air. Is traveling in air. Okay. A thin glass plate. A thin glass plate whose refractive index mu is equals to 1.5 of thickness 1 mm. 1 mm is placed in the path of light. Is placed in the path of light. The question is the change in phase of light. The change in phase of light is. Come on, say how much, how many of you can give me the answer? Everything is given in the data for me. The light of wavelength. How much is the wavelength right now for me? 5000 angstroms. Lambda is equals to 5000 angstroms. Is traveling in air. And when it has been traveling in air right now, like say here is a point A, and this one is right now for me point B. It is traveling in your air. Now this is your air. What is telling in the problem? A thin glass plate is being kept in between them right now. This is your thin glass plate whose refractive index is mu is equals to 1.5 and thickness of this one T is equals to 1 mm is being placed in the path of the light. The change in the path will be equal to how much? Anyone formula? Just now I told you the path difference formula. Delta x is equals to how much for me? Mu minus 1 into your thickness of your T. So that is equals to mu value is how much beta? Refractive index is 1.5 minus 1 into thickness is your 1 mm. Okay. So that will be equal to 1.5 minus 1 is how much beta? 0.5. Isn't it? This is your 0.5 into 1 mm is 10 power minus 3. So this will be 5 into 10 power minus 4 meters. This will be the answer. Okay. What is asking? The change in the phase is asking. Phase means delta x is your path. So phase value can be calculated with the formula. Delta phi will be equal to 2 pi by lambda into your delta x. That is equals to 2 pi by lambda is how much for me? 5000 angstroms. So it is 5 into your, this is your 5 into 10 power 3 into 1 angstrom is equals to 10 to the power of your minus 10. Isn't it? Into delta x. Delta x is 5 into 10 power minus 4. This 5 will get cancelled right now for me. Am I clear? So this will be equal to your 2, this will be equal to your, this one is 2 pi divided by, this is a 10 power plus 3 minus 10 will be equal to how much for me? But minus of your 7 into 10 power of minus 4. So simplify this one, how much I'm getting, you see? This will be equal to your 2 pi into 10 power minus 4. And this one will be plus 7. So that will be equal to 2 pi into 10 power. How much it is better? Minus 4 plus 7. How much it is? 3. So the answer will be equal to how much for me? 2000 pi will be the path difference. Am I clear? Am I clear?
Yes, sir.
Now 2000 pi means the phase will be equal to how much beta? What will be the phase? If I give the options like this one, 0, then pi by 2, then pi, and then 3 pi by 2. Which answer will you take? Path difference is 2000 times of your pi. How much? Phase difference is how much for me? 2000 pi. There is no difference in that one. So it will be equal to how much for me? 0. Isn't it? If it was in fractions, then you would have been try to calculate the value of your that given condition. If it is a 2 pi, 3 pi, 4 pi, that means it is forming exactly at your central maximum. Am I clear?
Yes.
Sure. और एक क्वेश्चन ट्राई करो. मान के चलो if we have got a transparent medium of refractive index mu is equals to 1.5 and thickness T is equals to 2.5 into 10 power minus 5 meter. Calculations are important. Okay. 2.5 into 10 power minus 5 meter is inserted in front of one of the slits of YDSC, Young's double slit experiment. The question is, how much will be the shift in fringe? Will be the shift in your interference pattern. Okay. Now the data is also given that the distance between the slits is given as 0.5 mm. 0.5 mm. And capital D, that means distance between slit and screen, is equals to 100 centimeters. So one is given in centimeters, one is given in mm. So you need to take care of your calculations whether the option is in centimeters or meters. I'm giving you the options right now here. Like say it is 5 centimeters, 2.5 centimeters, 0.25 centimeters, and 0.1 centimeter. So options are in centimeters. So try to convert that one into CGS system. So first write all the data, whatever he has given beta. How do you calculate the shift beta? What is telling in the problem? There is a screen, there is a slit right now here like this. And in front of this one, there is one small sheet is been kept. So because of that one, there is a shift in the pattern. Initially it was somewhere here. Now it has been gone here, right? This will be equal to central maxima. This is your capital D. These are the slit S1. This is a slit S2 and the distance between them is given as D. Now read the question. Within transparent sheet of refractive index mu is equals to 1.5. Thickness is given as of your 2.5 into 10 power minus 5 meter is inserted in front of one of the slit of IDSC. How much will the shift in the interference pattern? That means Y0 is equals to how much? The distance between the slit, that means small d is given as of your 0.5 mm and capital D is given for me. Capital D is given for me as 100 centimeters. Am I clear? Can anyone try me? What is the formula for this one will be using beta? Y0 will be equal to your mu minus 1 into thickness T into capital D divided by your small d. This is the formula which I told you. Whenever some sheet is being kept in front of this slit, one of the slit, the shift in the fringe pattern or the interference pattern is calculated by the formula mu minus 1 into T into D divided by small d. Now just keep the values and simplify the given condition. So shift will be equal to your this is given as refractive index 1.5 minus of your 1 into thickness. Thickness is given for me as how much? 2.5 into 10 power minus 5 meters. Then next one is right now for me capital D. Capital D is given as of your 100 centimeters. Isn't it? So that value is equal to how much for me? 100 centimeters divided by small d. Small d is given as of your 0.5 mm. Am I clear with this one? So everything you convert first into the meters, then you try to simplify the given condition, but that will be more easy. So 1.5 minus 1 will be equal to how much for me beta? 0.5. Isn't it? This is your 0.5 into 2.5 into 10 power minus 5 into 10 power 2. 1 centimeter is 10 to the power of your plus 2. 1 meter is equals to your 100 centimeters. Isn't it? So 100 centimeters is equal to your 1 meter. So I can directly write here as of your 1. In meters, if I'm writing, this will be equal to your 1. Am I clear? So if I'm converting it, I'm writing that one as of your 100. And 1 centimeter will be equal to how much beta? Anyone? 1 centimeter will be equal to 10 power minus 2 meters. So this will be 10 power minus 2 meters divided by your 0.5 into 1 mm is 10 power minus 3 meters. Remember, 1 mm is equals to 10 power minus 3 meters. 0.5 will get cancelled here right now for me. This value will be equal to how much? 2.5 into 10 power minus 5 into, just a minute, 10 power 2 into 10 power minus 2 into 10 power of your plus 3. Okay. So simplify it. See how much I'm getting, beta. 2.5 into 10 power minus 5 plus 2. This will be minus 2 into 10 power of your plus 3. How much I'm getting? How much I'm getting, beta?
2.5 centimeter.
2.5 centimeters. Right. From this one, first tell me in meters because we converted in meters now. So it is 2.5 into 10 power. This plus 2 minus 2 will get cancelled. Minus 5 and plus 3 will be equal to how much for me? Minus of 2. That means it will be your 2.5 centimeters. This will be the answer. Am I clear? Any doubt in this question?
No, sir.
Sure. This one question, buddy. A thin mica sheet of thickness. This question you need to do it better. Of thickness 2 into 10 power minus 6 meter and refractive index 1.5 is introduced in the path of your first wave. Okay. The wavelength of light used. The wavelength of wave used is 5000 angstroms. Okay. The central bright maxima will shift by how much? The central bright maxima will shift by how much? Number one, 2 fringes upward, 2 fringes upward, or 2 fringes downward. Third one is 10 fringes upward. And fourth one is 20 fringes up. Chalo, try. How do you calculate the shift? A thin sheet of mica of thickness. Thickness is given for me 2 into 10 power minus 6 meters. Refractive index is given as 1.5. Wavelength of the light used, lambda is equals to 5000 angstroms. How do you calculate the number of fringes shifted? Number of fringes shifted will be equal to how much, beta? N is equals to your, I told you, y naught divided by beta. How do you calculate y naught? Y naught is equals to mu minus 1 into your thickness T divided by lambda. This is the formula I told you. So N is equals to, it is 1.5 minus 1 into thickness T. 2 into 10 power minus 6 divided by wavelength. Wavelength is 5000 angstroms. So it will be equal to your 5 into 10 to the power of your 3 into your 10 to the power of minus 10. See how much I'm getting? 1.5 minus 1 is how much for me, beta? 0.5 into 2 into 10 power minus 6 divided by 5 into 10 power, this is minus 7. So this will be equal to how much, beta? 0.5 and this 2 will get cancelled. So this will be equal to 1 by 5 into 10 power minus 6. This will become for me plus 7. Minus 6 plus 7 will be equal to how much for me? How much? This is 10 power minus 6. This minus will go out. This will be your plus 7. Am I correct with the calculations? 1.5 minus 1.
Sir, answer 2.
2 into 10 power minus 6 divided by this is 5 into 10 power minus 7. How much better? 10 divided by your 5. That will be equal to 2. 2 fringes in which direction? Upward or downward? Upward only, no? Wherever you keep the thin sheet, in that direction it will be moving. I told you here, no? Like say, I told you this given condition. If it is kept in front of S1, it will try to shift in the direction of your S1 only. If you are keeping in front of Y2, it will be moving in the downward direction. Am I clear? Done?
Yes.
Sure. So by this, we are keeping full stop for the theory of your YDSC. Then we need to keep one session of a class for your problem solving. Let us try to go for the next topic of the wave optics. That is about your diffraction. Diffraction and polarization. Okay, very important part. Can anyone tell me what do you mean by diffraction? Anyone? Akshara, what do you mean by diffraction, madam? Bending of the light is known as what? Diffraction. Isn't it? When the light is going from the keyhole, you see that the shadow of the keyhole is larger. That means it is bending at the sharp corners. So indirectly, I can say that bending of your light, it is bending of light around corners, around your corners or edges, like sound, is called as of your diffraction. Okay. And one more thing you need to remember, the slit is of very large beta in this one. If slit size is large, diffraction is negligible. Diffraction is negligible. Okay, we can't see the diffraction. For diffraction to happen, it should be like a small hole. Like say if there is a small hole like this, when a light is being passed through this one, it will be bending on this one. So the shadow of this one can be seen on the screen like this. If the gap is very large and the light is going, it will almost all light go in a straight line without any deviations. Am I clear? So for the diffraction to happen, what should be the condition? The slit must be of very, very narrow or very, very small. Otherwise, diffraction can't be seen. Am I clear? So diffraction is negligible when the slit size is very, very large. The bending of the light is known as of what for me? Diffraction. Okay. So if slit size is small, then diffraction can be seen. Then diffraction can be seen. Example keyhole. Example keyhole. Am I clear? That means if the slit is small like this, opening, and the ray of light is being incident on this one, this all light will go in this one like this. And all this one will be acting as of your pair secondary sources on this. So from here, this ray of light will be going in this direction like this. But at corners, there is a bending of the ray of light like this. Okay. So this bending of the light at the corners is known as of your diffraction. Am I clear?
Yes.
Diffraction, one more name is also there, but can anyone tell me? It is also called as of your single slit diffraction. Previous was double slit experiment, and this one is called as of your single slit diffraction. Okay. So in single slit diffraction, first formula, Y max is being calculated by the formula. Y max will be equal to 2n minus 1 into lambda into capital D divided by your 2 times of your A. A is the distance of this slit beta. Like there we represented by small d, here we are representing the distance of the slit as of your A. That means minima of your YDSC is acting as maxima of your diffraction. Ulta. Am I clear? Minima of your interference, that is YDSC, is acting as maxima of your single slit diffraction experiment, where n value will be equal to 1, 2, 3, 4, go on. The same way, location of minima, Y minima will be equal to n into lambda into capital D divided by small a. So what is a small a? Small a is your slit width. And n value starts from here also 1, 2, 3, 4, go on. So A is your slit width. Don't go again much detail, and whatever is required, that much only I'm writing. Otherwise, unnecessarily you'll get confused. So how do you calculate the bright point in the single slit diffraction experiment? Single slit diffraction experiment, Y maxima or nth bright point is been calculated with the formula 2n minus 1 into lambda into capital D divided by 2 times of your A. And Y minima is n lambda into capital D divided by small a. Where is A? A is nothing but of your slit width. Am I clear? Sure. Now some more points. Maxima, minima, constructed distracted interference. Delta x will be equal to your, here it will be your A into sine theta. Previously it was D into sine theta. And that value will be equal to your 2n minus 1 into your lambda divided by 2. So path difference will be equal to your 2n minus 1 into lambda divided by 2. This is for what? Maxima. Okay. For minima. What is the path difference beta? Again, same formula. Delta x is equals to your A into your sine theta. That will be equal to your n into lambda. So maxima of your YDSC is acting as minima of your single slit experiment. Am I clear? And one more important formula. How do you calculate the width of central maxima? Width of your central maxima is given by the formula beta is equals to 2 lambda into capital D divided by small a. So this is your width of your central maximum. These are the formulas which you need to remember. If I explain you with the help of a diagram better, it is a single slit experiment. I'll just draw the screen here. This one is your screen. Okay. And in front of that one, we are keeping a small opening lens. Okay. So from here, the ray of light has been incident on the surface. The moment of the light has been incident, it will get bent. So here will be the ray and here will be the ray. That means at the central we are getting maxima, then followed by minima, then maxima, then minima, then maxima, then minima. Slowly intensity decreases. Here also the same thing here right now. This is minima, then it will be this one. So like this will be the given condition. Am I clear? So this represents for me your central maxima. So what is happening to the intensity? But as you're going up, intensity decreases. He'll ask you this question. Intensity is decreasing while you're going up. Am I clear? This is a slit width. This will be equal to your A. The distance between them I'm taking here as of your small d. Or you can even take this one as of your capital D. That's not a problem. Okay. Where is the first maxima formed better? Anyone can tell me? This will be the first minima. And this one is also your first minima. Okay. And here is right now for me. This is your first maximum. This is your first maximum. And here also for this one, this is your first maximum. Am I clear? Any doubt in this one? So what are the formulas you will be remembering in this one? But in the single slit experiment, y max has been calculated with the formula 2n minus 1 into lambda into capital D divided by 2a. Y minima has been calculated with the formula n lambda into capital D divided by small d. Now if I was asking the path difference for maxima, delta x is equal to a into sine theta, that is equals to 2n minus 1 into lambda divided by 2. That is representing me right now for me what? Maxima. This is for your maxima. The same way for minima, delta x is equal to a into sine theta, that is equals to n lambda. That is for your n min. Am I clear? Width of the central maxima is given by the formula 2 lambda into capital D divided by your small a. Clear? So let us try to do one problem based on this one. So we'll get an idea how the problems have been framed. Sure. A light source of 5000 angstroms. 5000 angstroms wavelength produces a single slit diffraction. Single slit diffraction. Okay. The first minima, Aksharano Japala Nagi. The first minima in diffraction pattern. Is seen. Everyone should give me the answer. At a distance of 5 mm from central maximum. Okay. The distance between screen and slit is 2 meters. Okay. The width of the slit in mm will be. The width of slit in mm will be how much? So the question. First option is 0.1. Next one is 0.4. Next one is 0.2. Next one is 2. Sure. It's light source of wavelength how much better? Lambda is equals to your 5000 angstrom of wavelength produces a single slit diffraction. And is asking first minima. For the first minima, what is the formula beta? Y nth minima is equals to your n into lambda into capital D divided by your small a. This is the formula. Na? N value here is how much beta? First minimum means n value is equals to your 1. At a distance of your how much beta? 5 mm. That means capital D is equals to your how much per meter it is? Slit, the distance between screen and slit is given as of here 2 meters. And the first minimum of the diffraction pattern is seen at a distance of your 5 mm. That means y value. Y is given as of your 5 mm. Okay. The width of the slit is asking. That means A value is equals to how much? Use this formula. Y first minima is equals to lambda into capital D divided by small a. So small a is equals to lambda into capital D divided by y. Lambda is equals to how much? 5,000 angstroms into 10 power minus 10 into capital D is your 2 meters divided by y. Y is equals to 5 into 10 power minus 3 meters. So everything I got in meters. So this is 5, this is 100. Okay, so simplify this one. How much I'm getting right now?
So 2 into 10 to the power minus 4.
Very good. So that will be equal to your 2000. That is right now for me 20. This will be equal to your 20,000 into 10 power. This will be equal to minus 7. So that will be equal to your 0.2 into 10 power minus 3 meters. So the answer is right now for me 0.2 mm. Am I clear? No doubt in this one? Am I clear with this problem?
Yes, sir.
Sure. One more question. Today I'll send you the 3 levels of papers on the waves beta, wave optics. One is the easy one, next one is medium, and next one is third. 3 levels of your questions of 45, 45, and 45. Easy, medium, and hard. Okay, so please try to do them, then we'll try to discuss the paper tomorrow in the class. So see this question. Tomorrow also there will be a class beta. A plane wavefront of wavelength 6,000 angstroms is incident on a slit of 0.2 mm width. Okay, which enables diffraction pattern. Which enables a diffraction pattern. Capital D is equals to 2 meters. Width of central maxima. Width of your central maxima in mm. In mm will be how much? Options are 10, 12, 8, 2. Sure. Anyone, what is the formula for the central fringe beta? Width of the central fringe. I told you this formula here. Let's see. Width of the central maxima. Beta is equals to 2 lambda into capital D divided by A. So what is the formula I'll be using here? Beta is equals to, this is a 2 lambda into capital D divided by small a. So it is equals to 2. Wavelength is how much for me? 6,000 angstroms. So this is 6,000 into 10 power minus 10 into capital D is your 2 divided by A. A value is given how much for me? 0.2 mm. So it is 0.2 into 10 to the power of minus 3. Okay. See how much I'm getting right now for this one. This 2 will get cancelled. So this will be equal to 3. And this will be equal to 10. This will be equal to minus 6. This will go here right now. This will be equal to minus 3. That means this will be equal to 6 to 12. It will be your 12 mm. This will be done. Am I clear? Done, beta?
Yes, sir.
Sure. So we have almost all done with your all the formulas of your diffraction and as well as of your interference. Tomorrow we'll try to do with your polarization. Polarization is very important, beta, and it will take some time because the problems on that one are also very understandable and very good. So we need to understand the way of the problems, orientations, and tilting. So tomorrow we'll keep the full stop for the polarization. Then we'll try to start doing the numericals. Okay. Sure. Take care, beta. Bye.